students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we are going to solve the top 30 previous year questions from the chapter Equilibrium. Okay, so we have completed this chapter, so today we'll solve some questions and we will see how much how much we have understood the concepts and are we able to apply them in these questions or not. Okay, and one more request is please join our WhatsApp channel, link is there in the description section, and this will help you to get access to all our PDF notes, class notes, everything. Okay, so now let's get started with the first question. The category of these question is properties of Kc. One more thing I want to add here, that if you see, since it is a PU1 chapter, if I consider last 10 years of question also, I could find only 14-15 questions. So I have included Comet K previous year questions as well, because the level is almost same, so make it top 30 questions. Okay, so the first question here is, at 500 Kelvin for a reversible reaction A2 plus B2 gives 2AB. In a closed container, Kc is equal to 2 into 10 to the power of minus 5. In the presence of catalyst, the equilibrium is attaining 10 times faster. The equilibrium constant K in the presence of catalyst at the same temperature is 2023 question. So we know that equilibrium constant is dependent only on the temperature. It is not affected by the presence of the catalyst. So whatever was the equilibrium constant before, same will be now also. So 2 into 10 to the power of minus 5 will be the correct answer here. Okay. Next is question number 2. The equilibrium constant for the reaction is 4 into 10 to the power of minus 4 at 2000 Kelvin in the presence of hello. In the presence of a catalyst, the equilibrium is attained 10 times faster. Therefore, the equilibrium constant in the presence of catalyst at 2000 Kelvin is, you can see the same concept question is again repeated, and still we know now that catalyst will not affect the equilibrium constant. It will still be 4 into 10 to the power of minus 4. So option number C is the correct answer here. Okay. Next question number 3. For a reversible reaction, if the concentrations of the reactants are doubled, then equilibrium. Again here also see, if you change the concentrations initially, okay, then also equilibrium constant will not change. It will be affected only by the concentrations of the reactants and products at equilibrium, right? So that is why here also it remains same. Question 2020, option number A is the correct answer. This is Comet K PYQ. Next is question number 4. Now we'll go to applications of Kc. If you remember, we have 3 applications. The first one is to predict the extent of reaction. The next one is to predict the direction of reaction. And the third one is to calculate delta G. Right? These are the 3 applications. So this is about your direction of reaction. The reaction question Q is useful in predicting the direction of the reaction. Which of the following statement is incorrect? 2017 question. If Q is greater than Kc, the reverse reaction is favored. Yes, that is correct. If Q is less than Kc, then forward reaction. This is also correct. If Q is greater than Kc, forward reaction is favored. This is incorrect. So option number C is the correct answer. Question number 5 now. Comet K question again 2020. For the reversible reaction A plus B gives C plus D, delta G value is given. Which one of the following statements is true? Okay, the entropy change is negative. No, if you see, we have more number of gaseous molecules on the product side, right? So entropy change is positive. So this is incorrect statement. Equilibrium constant is greater than 1. If you check this one, delta G equal to minus 2.303 RT log of K. Okay, so now what you can do is, if you solve this, delta G value is minus 350 into 10 to the power of 3, right? 2.303 into 8.314 into temperature is not given. Okay, fine. If we find this value, okay, definitely suppose for any temperature T, if you find this K value will be definitely greater than 1. Okay, but if we do not know, let us leave this. We'll see the next option. The reaction should be instantaneous. Here question students may get confused. Instantaneous reaction and spontaneous reactions are two different things. Instantaneous means the reaction can happen immediately. Like suppose for example, if you add water to acid, the explosion that takes place, that is instantaneous. Spontaneous means it takes by its own, but it is not immediately. Okay, so that is why the reaction should be spontaneous is correct, but instantaneous doesn't make any sense. The reaction is thermodynamically not feasible. No, if delta G is negative, then the reaction is feasible. So this is also incorrect. So we need only one option, that is option number B will be the correct answer by default, right? Next question number 6 is on equilibrium constant, the major most important topic. 1 mole of HI is heated in a closed container of capacity 2 liter. At equilibrium, half a mole of HI is dissociated. The equilibrium constant of the reaction is. Now let us see. Suppose we have this one 2HI, right, dissociated to give you H2 plus I2, right. Initially we have 1 mole of HI, right, and this was 0 and this was 0, right. After that what happened? Some amount got dissociated, and after dissociation at equilibrium, what was there? Half a mole of HI was dissociated. 1 mole was already there, half mole dissociated. So how much is left? 1 minus half, right, dissociated. Now see, 2 moles is giving you 1 mole. Half mole will give you 1/4, and this one will also be 1/4. So at equilibrium we are left with this is 1 by 2, this is 1 by 4, and this is 1 by 4. Now these are what? Number of moles, but we need to calculate the concentration. So what is the concentration of HI? Number of moles by volume. Number of moles is 1 by 2, right, and volume is 2 liters. So I'll get 1 by 4. Now similarly, concentration of H2 is equal to concentration of I2 is equal to 1 by 4 divided by 1 by 2, I'll get 1 by 8. Right. Now if I want to calculate Kc value, that is H2 concentration into I2 concentration divided by HI whole square, right. Now what is H2 here? H2 is 1 by 8, this is 1 by 8, okay, and HI is 1 by 4, right. So it will be 1 by 4 by, so I can write, it will get reversed like this, right. So if I solve it, I'll get 1 by 4, that is 0.25. Okay, so the correct answer for this question is option number A here. Next question number 7. The relationship between Kp and Kc is this one. What would be the value of delta N for the reaction? Now if you remember, what is delta N? Delta Ng is equal to number of moles of product, right, minus number of gaseous moles of reactants. Okay, so you see here it is, I have product side, it is 2 minus 0, that is 2. So delta Ng will be 2. Correct answer is option number D here. Next question, in the reaction FeOH whole 3 Fe3 plus 3 OH minus, if the concentration of OH minus is decreased by 1 by 4 times, then the equilibrium constant will increase by. Now sorry, the equilibrium concentration of Fe3 plus will increase by. So if you see, if I write this Kc value for this one, that is OH minus cube, okay, and Fe3 plus. Right, this will be the value. Solid, pure solid concentration is taken as 1, so this is the value. Now the question is asking OH minus concentration is decreased by 1 by 4 times, right. So I'll write 1 by 4 of OH minus cube, and then we have Fe3 plus, right. So that is equal to 1 by 64 into OH minus cube, and we have Fe3 plus. Now what happens? See, I told you at equilibrium the concentration will not change. The equilibrium constant has to be a constant term, right. Now if this one is decreasing, this has to increase by that many times. So it will increase by 64 times so that the final value remains same. So it will increase by 64 times. Okay. Next question, equilibrium constant K1, K2 for the following equilibria is given, okay, and they are related as. Okay. So now if you see, the first one reaction, you see NO is on this side, NO2 is on this side, and in the second reaction NO2 has come towards the left hand side. That means this reaction has been reversed. So what I'll do, reverse reaction number 1. So what I will get here, NO2 is giving NO gas plus half O2. Okay, this is there. So what will be the value of K? If you reverse the reaction, the K value becomes 1 by that one, right? So here I will write it is 1 by K1 now. Now what I'll do, I'll multiply 2 to the whole equation because I need 2 NO2. So 2 NO2, 2 NO, and this will become O2. So now if you multiply 2 to the whole equation, it will become K1 square, right? So K2 is equal to 1 by K1 square. Option number D is the correct answer in this question. Okay, next, for the equilibrium, CaCO3 gives CaO solid plus carbon dioxide gas. Kp is 1.64 atm at 1000 Kelvin. 50 gram of calcium carbonate in a 10 liter closed vessel is heated to 1000 Kelvin. Percentage of CaCO3 that remains unreacted at equilibrium. Okay, so now what we can do here is, we have this equation, right? The CaCO3, okay, is giving you CaO plus CO2. This is gas, right? And these all are solid. So I can write Kp is equal to pressure of CO2, and that is equal to 1.64 atm, right? Now, if we have pressure of CO2 is 1.64 atm, then we have this formula PV is equal to nRT. So we can calculate N value, right? So what is N value? PV by RT. So P is 1.64, V is 10 liter, right? R is, I'll take 0.082, okay, and temperature is 1000 Kelvin, right? Yeah, if you substitute and calculate, you will get N is equal to 0.2 moles, right? So N is equal to 0.2 moles. Now in this reaction, you started with 50 grams of CaCO3. Then what was the moles of CaCO3? It was given mass by molar mass, that is 0.5 moles, right? 0.5 moles was there, and at equilibrium 0.2 moles are there, right? 0.5 mole was there and equilibrium 0.2 mole is there. Why I am saying? See, 1 mole is giving you this one 1 mole. So if this one is 0.2, then this one also would have reacted 0.2, right? So 0.5 was there, 0.2 was reacted, then NaCaCO3 that is left is equal to 0.5 minus 0.2, that is 0.3. And if you want to calculate in terms of percentage, that is 0.3 by 0.5 into 100, that is 60. Okay, option number C is the correct answer here. Next, question number 11. For the reaction 2NO2 gives N2O for gas, Kp by Kc is equal to. Okay, so if you see here, what is delta Ng formula? Delta Ng is 1 minus 2, that is minus 1, right? So now if I see Kp by Kp is equal to Kc into RT to the power of delta N. Delta N is minus 1. So I'll write Kp by Kc is equal to RT to the power of minus 1 or 1 by RT, right? So that is option number A here. Okay. Next, question number 12. So students, let us see the next question, that is question number 12 here. This was a Comet K PYQ of 2022. So 2SO2 plus O2 gives you 2SO3, 1.5 moles of SO2 and 1 mole of O2 are taken in a 2 liter vessel. At equilibrium, the concentration of SO3 was found to be 0.35 moles per liter. Then the Kc for the reaction would be. Okay, so this is little I can say lengthy question. You can solve like this: SO2 plus O2 gives what? 2SO3, right? Now let the initial moles are also given 1.5 and this is 1, right? And if you know that the volume is 2 liter, right? So what will be the concentration? 1.5 by 2, 1 by 2, right? And this was 0. This is at T equal to 0. Next, at equilibrium, some amount must have reacted. So let 1.5 minus x by 2 is remaining after the amount has reacted. Now see, 2 moles is reacting with 1 mole. So x mole will react with x by 2 moles. So I can say 1 minus x by 2 by 2. Okay. Now here the amount, the concentration of the SO3 at equilibrium is 0.35 and that will be X. Now why I am saying X? See, because 2 moles is forming means you will get 2 moles. So if X is forming, you will get X moles, right? So the concentration will be X by 2 here. Now according to the question, this X by 2 is nothing but 0.35. I can put X is equal to 0.7, right? Now we can substitute all the values. What is the concentration of SO2 then? SO2 is 1.5 minus 0.7 by 2. So that is almost 0.4, I think. Yeah, that is 0.4. And next, if I substitute, what is the value of O2? O2 value will be 1 minus 0.7 by 2. 0.7 by 2 is 0.35, right? Divided by again 2. So that is 10 minus 5, 5, 9 minus 3, so 0.65 by 2. So it will be 0.325, right? That is O2 concentration is 0.325. Next, what I have SO3 concentration is already given in the question, that is 0.35, right? So SO3 concentration is already 0.35. Okay. Now if I want to write the value of Kc, okay, that will be equal to SO3 square divided by SO2 square and O2. Okay. So now if I write SO3, SO3 will be equal to, concentration of SO3 is 0.35 square. Okay. Now SO2 value is 0.4 square and O2 value is 0.325. Okay. So now if you solve this, you will be getting around 2.36. So correct answer for this question will be option number A. Let us see the next question here. If Kp for a reaction A plus 2B gives 3C plus D is 0.05 atm at 1000 Kelvin, its Kc in terms of R will be. So we know this formula, Kp is equal to Kc into RT to the power of delta N, right? Now if you see, we have Kp value is 0.05, right? Kc value is there and temperature is 1000, right? So 1000 times R, and what is the delta N value? Here you can see 3 plus 1 4 and 2 plus 1 3, that is 1. So 5 into 10 to the power of minus 2 divided by 10 to the power of 3 into R, right? So it will be 5 into 10 to the power of minus 5 divided by R. Option number D is the correct answer here. Okay, next Le Chatelier principle question. For the reaction A plus B gives you C plus D, the equilibrium constant cannot be disturbed by. So if you do addition of A, equilibrium constant will disturb, addition of D will also disturb. But if you increase the increase of pressure, okay, if you do increase of pressure, now you see both the side there is no like number of gaseous molecules are same on both the side, so there will be no effect of increasing of pressure. So that is why option number C is the correct answer. Okay. Next is from acid base theory, the conjugate base of NH3. Okay, so if I remember, if you want to find conjugate base, what you need to do, you need to remove H plus, right? So if I remove H plus from NH3, it will become NH2 minus. Option number C is the correct answer here. Next, which of the following is the strongest base? So if you remember, weak acid, okay, will have strongest, weak acid will have strongest conjugate base, and out of these all acids, that is HCl, H2O, CH3OH and CH3COOH, water is the weakest acid, so its conjugate base will be the strongest. Option number B is the correct answer here. Okay, next, acidity of BF3 can be explained on which of the following concepts? So if you remember, Lewis concept tells you that anything which can accept a pair of electrons is a Lewis acid, right? So BF3 is electron deficient, it can accept electrons, so that is why it is an acid according to Lewis concept. Okay. Next, 18, the pair of compound which cannot coexist together. So if you see here, we have NaHCO3 and water, they can coexist together definitely. Na2CO3 and NaOH, NaHCO3 and NaOH. So if you see this one, NaOH plus NaHCO3, right? So what will happen here, this one can donate H plus and this one can accept an H plus, so we will get Na2CO3 plus H2O. Okay, so this two will react to give you salt and water because it is an acidic one, this is a basic one, they cannot coexist together. Option number C is the correct answer here. Okay, next we'll go ionization constants of acids and bases. So the Ka values for the acids are given to you, H2SO3, okay, then you have HNO2, next we have CH3COOH, and then HCN. Okay, these are the different acids present, and we have 1.3 into 10 to the power of minus 2, then 4 into 10 to the power of minus 4, then you have 1.8 into 10 to the power of minus 5, and 4 into 10 to the power of minus 10. So now you see, if the Ka value is least, okay, we'll have the strongest conjugate base. If the conjugate base has to be strongest, then the acid has to be weakest, right? And to know the weakest acid, the Ka value should be least. So that is why it has to be HCN. Option number D is the correct answer here. Next, question number 20. For a polybasic acid, the dissociation constants are given. What is the observed trend in the dissociation constant? So we know once one H plus is removed, then you have to remove a proton from a negatively charged species where the electrostatic force of attraction is more, so you have to give more effort, right? So that is why here Ka1 will be highest. This one is not willing to give you H plus because it is attracting that H plus stronger with respect to this one because it is a negatively charged species. So here H plus will be very difficult, so acidity will decrease, Ka2 will decrease, here further it will decrease. So Ka1 is greater than Ka2 is greater than Ka3. Next, question number 21 is on pH scale. Which among the following has the highest pH? So now if you want to calculate highest pH, right, that has to be a base because acids have low pH, so we can eliminate these two options. Now if you see these two options, here what is the OH minus concentration? OH minus concentration is 10 to the power of minus 1. Then what is POH value? POH value will be 1 minus log of this one. Then what is pH value? 14 minus 1, so that is 13 here. Now if you see, this is option number B. Now if you solve in option number D, OH minus concentration is what? 1 molar, right? Then what is POH? That is minus log of 1, that is 0, right? So what will be pH value? That is 14. Okay, option number D is the correct answer here. Next, question number 22. 1 mole of ammonia is completely absorbed in 1 liter solution each of HCl, CH3COH and H2SO4 at 298 Kelvin. The decreasing order of pH of the resulting solution is. You need to calculate the decreasing order of pH. Okay. Now see, if it is a basic salt, then the pH will be higher, right? And NH3 and CH3, NH3 is a strong base and CH3COH is a weak acid. So the salt of that one will be a basic salt, right? A basic salt pH will be higher. So definitely 2,1 will be higher. So we can eliminate these two. Now coming to next one, H2SO4 and HCl. Definitely HCl is a stronger acid. So that means the, H2SO4 is a weak, if you compare H2SO4 and HCl, right? H2SO4 is a stronger acid, so this salt will be more acidic, its pH will be less, right? So the pH of H2SO4 will be least and in middle we will have HCl. Option number C is the correct answer in this question. Next, 5 liter of NaOH has pH of 12 contains. Okay, so if that has pH of 12, then what is the value of POH? That is 14 minus 12, right? That is equal to 2. So OH minus concentration is how much? 10 to the power of minus 2. Okay, this is OH minus concentration in moles per liter. Okay, now if you take 5 liter, in 5 liter what will be the concentration? 5 into 10 to the power of minus 2. Okay, moles. Now if I want to calculate the mass, mass is what? Number of moles into molar mass, right? So that is equal to 5 into 10 to the power of minus 3 into, 5 into 10 to the power of minus 2 into 40. So I'll get 5 4s are 20, into this into 10 to the power of minus 2, and that is 2 grams. Okay, option number D is the correct answer here. Next, question number 24. On base of salt hydrolysis, a salt of weak acid pK 5.9, pKb 5.8 are mixed in equal proportion pH. So if you remember, pH formula is 7 plus half pKa. pKa value is 5.9 minus half of pKb, that is 5.8. Okay, 7 plus half pKa minus half pKb. So if you solve this, you will be getting around 7.05. Option number D is the correct answer here. Next, question number 25. The solubility product of BaCl2 is 3.2 into 10 to the power of minus 9. What will be the solubility? Okay, so if you see BaCl2, okay, I have told you formula: x to the power of x, y to the power of y, s to the power of x plus y is equal to Ksp. Right, here x is equal to 1, y is equal to 2. Right, so I can write 1 to the power of 1, 2 to the power of 2, s to the power of 3 is equal to 3.2 into 10 to the power of minus 9. Okay, so now it will get, I think we'll have 4 into s cube is equal to 3.2 into 10 to the power of minus 9. So that will be equal to 4 into 0.8 into 10 to the power of minus 3, and can be approximated to 1 into 10 to the power of minus 3. Option number C is the correct answer here. Next, question number 26. Solid barium nitrate is gradually dissolved in 0.1 into 10 to the power of minus 4 Na2CO3. At what concentration of barium 2 plus will a precipitate begin to form? So here if you see, we have Ksp, okay, of this one. Barium carbonate is what? Ba2 plus and CO3 2 minus, right? So what is the Ksp value for this one? 5.1 into 10 to the power of minus 9. Okay, and barium 2 plus concentration we need to find out. Okay, and CO3 2 minus concentration is given to you as, sorry, barium concentration is 1 into 10 to the power of minus 4, right? This barium is coming from where? Barium nitrate, and its concentration is 10 to the power of minus 4. Carbonate concentration we have to find from here. No, sorry, the first one was correct. Barium concentration we have to find. Carbonate concentration is given to us as 10 to the power of minus 4. So now if I do this one, I will get 5.1 into 10 to the power of minus 5. Okay, that is option number B. Next, question number 27. Solubility product of, so this is 2024 last year question, I mean this year question. Solubility product of CaC2O4 at a given temperature is in pure water is this one. Then the solubility is how much? So if you see, it will dissociate how much? CaC2O4 will dissociate to give you CaC plus C2O4 2 minus, right? S and S. So Ksp is equal to S square. So now what is the value of Ksp? 4 into 10 to the power of minus 9 is equal to S square. So S is equal to root over of 4 into 10 to the power of minus 9. Here you should be very careful. It is can be written as 0.4 into 10 to the power of minus 8 is equal to S. Now if I take square root of this one, we will get 6.3 into 10 to the power of minus 5. Here many of you might have written these options, so you should be careful. Here it is, you have to make it an even number to take square root. Okay. Next, question number 28 is on common ion effect. In the presence of HCl, H2S results in the formation in the precipitation of group 2 elements but not group 4 elements during quantitative analysis. It is due to. So if HCl is present, okay, how does H2S should dissociate? It should dissociate to give you 2H plus S2 minus. Now if H plus is present in the solution from HCl, right? HCl will dissociate to give you H plus and Cl minus. Now if this is more, it is present in more amount, then what? Backward reaction will prefer and H2S will form and the concentration of S2 minus will decrease. So that is lower concentration of S2 minus, option number D here. Okay, next question in the analysis, so this is also 2024 question. In the analysis of group 3 basic radicals, the purpose of adding NH4Cl is, okay. So now if you see in group 3 analysis, we use the solvent NH4OH, right? So now if you add NH4Cl to that, what will happen? This one it should dissociate to give you NH4 plus and OH minus, right? Now if NH4Cl is present, this ion increases, so the backward reaction will take place and the dissociation of NH4OH is suppressed by using common ion effect, right? So that is why it is added. Option number C is the correct answer. Next, the solubility of AgCl is least in, so again based on common ion effect, you can say more is the chloride ion, less will be the solubility. Option number D is the correct answer here, okay. So now if you see the most important topics, you can see properties of Kc 3 questions are asked, application of Kc 2 questions, equilibrium constant 8 questions, okay. So prepare as many questions as possible from equilibrium constant, okay. Next, if you see acid base theory 4 questions, pH scale you got 3 questions, solubility and common ion effect 3 questions. So if you want to prepare these chapters, make sure that you are doing these important topics from this particular chapter, okay. So yes students, that's all in this class. So please subscribe the channel and see you soon in the next class. Thank you for watching.